see the formation of image through convex lens. For this I have taken one source. So in that source you would see that a shape L, an English letter, is there. The next, this is the convex lens of 100 millimeters or 10 centimeters, and then this is the screen on which I am going to obtain the image. Now let's arrange this. Now we can see I have taken the distance from the source to the lens as 20. That means I kept the object at 20 centimeters away from the lens. So this is acting like an object for me. So the object is 20 centimeters away from the lens. Now if you measure the distance, here also it is exactly 20 centimeters. So that means we can confirm that if the object is 20 centimeters away, that is nothing but twice the focal length. If the object is at 2f, then the image is also obtained on the other side of the lens at the same distance 2f. Now if I take this lens, move this lens towards the object, you can see the image clearly. So here if you talk about this image, it is inverted, but the size of the image remains same. Whatever the size of the object is there, it is equal, and it is real image, it is inverted image. Now the distance between the lens and the object is 2f, then the distance between the lens and screen is also 2f. Now what we do, we just move this nearer to this object. Then now the position of the object is in between the 2f and f. So roughly I have taken some 12 centimeters here. Now you can see that a clear image is formed at a distance more than this 30, and then this is almost all some 10 centimeters, that means 40 centimeters. So that means if the object is kept from the lens in between f and 2f, that is here remember the focal length of this lens is 10 and 2f will be 20. So if I take some 12 or 15, then the image is moved far beyond 2f. So, and here if you see this shape, this shape is definitely a magnified image is formed. Now here this is also inverted. We are able to obtain this on the screen, therefore it is real, inverted, and then magnified or enlarged image. Now if I do the reverse of it, that means if I take the object beyond 2f, that is, now it is just reverse of it. So if the object, we know that this is the object here, the distance from the lens to the object is more than 2f, then the image is formed on the screen is diminished, inverted, and it is real as we are able to obtain on the screen. Now if the object is kept at focus, that means exactly at 10 centimeters. Now let me shift this to 10 centimeters. Then we will be able to obtain the image very far off. You can observe this. We can observe this, the very far off this one. So when we compare the focal length, that is 10 centimeter, to this distance, you can consider as if it is very far off or infinity. So when the object is kept at focus, the image is formed at infinity. So these are the different positions when we keep the object where we get the image that we have discussed. The very first arrangement we have discussed at 2f, the image is also formed at 2f. The magnification is equal to 1 because the size of the object and size of the image are same. Now when we move this object nearer to the lens, that means when we keep the distance below 20 centimeters, then the size of the image was enlarged. Now if you do the reverse of it, when the object is kept beyond 2f, then you have seen that the image is a bit diminished, and in all the cases we have observed that a real image is obtained. What do you understand by a real image? Real image means an image which is obtained on the screen. Suppose if you make use of the other kind of lens, here it is convex lens. If I take concave lens, you will never get an image obtained on the screen. That means it is not a real image, it is virtual image. So these are the details of the formation of image through convex lens.